So I'm pleased here to welcome Patrick Gundlach. Patrick is from Berlin in Germany. Last year, he gave a great talk about tools he is developing, speedata, to automate the publication of catalogs of products. And from what he told me, since last year, he hit some limitations of the tech engine, and that's why he will be presenting now. So Patrick, it's up to you.
Okay, hello. Thank you, Jeremy, for the introduction. And I'd like to present a project of mine, which I've been working on for the last few years. This is a live presentation and not pre-recorded, so I hope the internet connection is good enough for that. The project I present is called Boxes and Glue, and it's named after TeX model of joining rectangular boxes together with flexible width. So this presentation is aimed at developers, but I hope that even if you're not a developer yourself, there's still some interesting slides for you. Before I show the why and the how in detail, I try to give a short overview of Boxes and Glue. This doesn't work. Okay, let me try. So what is Boxes and Glue? Boxes and Glue is a collection of software libraries, and therefore it's not a ready-to-run piece of software or program such as TeX. The library is written in the Go programming language and is an attempt to bring TeX superb typesetting quality to a modern environment. And it's available under an open source license. So why Boxes and Glue in the first place? Jeremy has already said that I'm self-employed and work on creating product catalogs and data sheets from databases. So it's a fully automatic and unattended workflow where you have the data and the layout in advance. And then I use LuaTEX or my software on top of LuaTEX to create PDF catalogs. And LuaTEX is used as a typesetting backend, and my software arranges the visible elements on the page depending on the provided data and layout instructions. There are a few examples here on the slides and also on my homepage. So how does it work? A PDF page consists of many little items such as glyphs, rules, images, colored areas, and other rectangular shaped things that can be joined together in a horizontal or in a vertical box, which themselves can be placed in boxes until there's one big box that represents the page. All the things and rectangles are called nodes in TeX. Now with LuaTeX, you can jump into the Lua mode, which allows you to do anything that could be done from the TeX side, just with a different programming interface. So for example, to create a glyph output from Lua, you have to create a new node, that's what it's called, of the type glyph, and fill in the fields. The font, for example, has to be loaded in advance to get the glyph dimensions. And just as an example on how to create a horizontal box, like an H box in TeX, the code is shown here. The real code that has to be used is of course much more complicated. This looks a bit tedious, and especially compared to TeX input, it really is tedious. But with enough abstraction, it is quite doable. So this is the way you assemble pages in LuaTeX. So why LuaTeX in the first place? Well, LuaTeX is an awesome piece of software and it's really, really fast. You might not believe me. Oh, there's a video here. So it was a bit fast. Let's go back. I hope you can see it all. So what does it do? It's a video of a terminal on my Mac, and it calls, the program is LuaTeX, and on a document called mf.tex, which is the documentation of Metafont, the program. And the time is measured how long it takes to run the software. So let's play the video again. So it's 499 pages, and it takes about, that's the last line, 1 second, a bit more than 1 second to create almost 500 pages in LuaTeX. And I think this is really, really fast. So LuaTeX has also all features of TeX, but I think it's better programmable. I don't like the input language of TeX very much. And LuaTeX is very flexible. You can create almost any PDF code you want to comply with a huge range of PDF standards. And LuaTeX contains HarfBuzz. And HarfBuzz is the text shaping library, which loads a font, and you can ask HarfBuzz to turn a series of characters into a list of glyph IDs from that font. So this is trivial for a single letter such as A, but it gets comes in handy when you have complex ligatures or non-Western scripts such as Arabic, where the glyph shape depends on the position of the character in a word, and it also interprets OpenType features. So HarfBuzz is a very valuable library. And I'm not the only one who thinks that LuaTeX is an awesome piece of software. Also, this football guy from Italy is a big fan of LuaTeX. And by the way, thank you, Paolo, for this image. So, but my talk is not just about praising LuaTeX. LuaTeX has, in my opinion, a lot of shortcomings, and it's very subjective, I know. Error handling in LuaTeX is sometimes really awful. Sometimes the only error message I get is, this cannot happen. Or might sound trivial, but you cannot create HTTPS connections to a web server. And in almost every other project of mine where produce catalogs, I need to get images from a web server from an image database. And this is, of course, connected with HTTPS. And there's no garbage collection of these Lua nodes, which makes manual memory management necessary. And this is also very subjective. LuaTeX, I think, is only suitable for smaller projects. There's no type checking for variables, and there's no good tooling, in my opinion, for the language, especially compared to other languages. It's hard to extend because it's still TeX, and TeX is not known for its modularity. And I have the necessity to compile LuaTeX or my software around LuaTeX for different platforms. And this is really hard to do when you have lots of libraries around. And LuaTeX, there are little things, many little things that can be annoying. For example, I don't know if it's still true, LuaTeX on Windows is not able to be installed in the directory with a non-ASCII character in the path name. Or at one time, also on Windows, LuaTeX was unable to include an image or other assets with non-ASCII characters. So these things can be annoying. So these limitations hit my daily work more and more. So I'm thinking about re-implementing TeX for quite a long time now. The good thing about TeX is being open source. So you can, and it's well documented. So you can download the documentation. It's a documented source code, or you can get Knuth's book called Computers and Typesetting B and study TeX source code. There has been a re-implementation of TeX before. It was called NTS and was written in Java, but as far as I know, it has never taken off to be used in the real world. And there was a project called XTeX, which took the NTS code, but I think this was also abandoned. So I see three possibilities to re-implement TeX. The first is to go from the Pascal code in the book and translate it one by one into a modern environment. But this would still be TeX output, an output DVI, and would not load OpenType fonts. So the second way could be to take the source code or the C code from LuaTeX and translate it, or use some automated translator like a transpiler to create code, for example, to the Go programming language. But there's still a lot of dependencies on C libraries, and the code would not become modular automatically. So the last option is the one I take. It is to re-implement the system by looking at what needs to be done and not how it is done. The footnote here is that I do limit myself to the application I have, and I would just port a subset of the current implementation of LaTeX, LuaTeX. So now when I think of re-implementing TeX, I have to take into account compatibility with TeX. Take, for example, the function here from the TeX source code to calculate the badness when, for example, a line of text in a paragraph has to be stretched to a given horizontal size. It should be obvious what this function does, right? Well, it wasn't for me, and I can show the formula that it implements. In a modern programming language, this would be like this, just a one-line code. So the question I have to answer is how compatible I would like to be with original Knuth TeX. The code to the left computes only 1,095 different values, but it's probably very fast and also entirely incomprehensible. Since my goal is to be only similar to TeX, but not exactly alike, I would take the one-line calculation of the badness, which does not give the same results, but is good enough, and I think it's clear enough. So this is my approach to compatibility, not to be exactly like TeX, but to do the same. So when I write everything from scratch, I have to take a close look which parts of TeX or which algorithms in TeX I want to re-implement. So from my point of view, the most important algorithms in TeX are hyphenation, the famous breaking paragraphs into lines, but also math typesetting, the calculations with glues, and the input language, which is based on macro expansion. And these algorithms are very well documented and very clever, but it's not rocket science to implement those. It's doable. I would like to show you the cleverness of these algorithms with one example, the hyphenation algorithm to split words into smaller parts. The starting point is a list of hyphenation patterns, which look like this. And I'm not going into detail how this list is created, but it's a mixture of automatic extraction from dictionaries and lots of manual labor. On the right-hand side, there's a small excerpt of the German hyphenation pattern file, which has about 25,000 entries. Each entry consists of letters and numbers and dots, which match the start and end of the word. Now let's take a word to hyphenate, a German Autobahn, of course, and we insert letters, spaces. You will see in a second why. We go through each entry in the pattern file, or pattern list, and try to match each pattern to the word. The first one doesn't match, but let's take a look at the second. So it matches because you can put it right beneath these letters from the original word. So the next pattern, like 1TO, does not have a number between T and O, and we assume it's 0. So we can put it here in this place. Now we go through each line or each entry in the pattern file and keep on going and try to find more and more entries which match the original word. And now we're done. There are no more entries in the pattern file which can be written down here. So what do we do now? Where do we go from here? So we are only interested in the numbers between the letters. The idea is to get the highest number in each column. Between A and U, the maximum is 2. U and T, the maximum is 1, and so on. So we write down there. Now, an odd number means a valid hyphenation point at this point, and even numbers mark unbreakable points or parts of the word. So that's the way this algorithm works. But the algorithm is rather simple and can only return a signal where hyphenation is allowed or not allowed, but it cannot give you a priority or a preference where it is more feasible to break or less feasible. And I will come back to this at the end of the presentation. I have some design goals for boxes and glue. The first one is obvious. It's TUG-like typography and output quality. We don't need to discuss that. And boxes and glue should be as fast as LuaTEX. Text internal data structures, which I've mentioned before, the nodes, are very well suited for representing a typesetting problem, I think. So I take all the programming around the nodes from LuaTEX and put this in boxes and glue. And with Arabic, I mean all kinds of non-Western scripts which are encoded in Unicode, and they can be mixed left to right or right to left text. So this should be possible with boxes and glue. And I'd like to support PDF standards such as accessibility and other well-known standards PDF. But I also do have some non-design goals. Considering that I want to use the software as a replacement for my catalog software that I currently use, I don't need TeX compatibility. Only the output should be similar. And all 8-bit related stuff and DVI is not considered to be part of boxes and glue. I only need OpenType fonts and PDF. And I don't need the input languages, input language for my purpose. So how is the library organized? It's actually split into two parts. There's a backend with some core functionality, which is absolutely necessary to create PDF documents. And this is the part where I have implemented those TeX or discussed TeX algorithms, like breaking paragraphs into lines. And there's a nice to have front end, which contains the nice to have or optional code, which makes live or implementation easier. And of course, since this is a library, one needs an application to use boxes and glue. I currently experiment a lot with HTML typesetting because I need this quite often. But my real test case is a new version of the speedata publisher, which runs on boxes and glue, since this is the goal of the whole project, to replace LuaTEX. Here I've tried to estimate how much progress I have made in each module. So the backend is more or less feature complete, and the front end needs a lot of work. For example, the page layout module on the right in the front end should provide a page layout with headers and footers and footnotes and margin and so on, similar to LaTeX output routine. So the users of the library don't have to reinvent the wheel for every new application. So I've tried to break a paragraph into lines with LuaTEX and with boxes and glue. And for LuaTEX, I have disabled microtype, the HZ program, because this is not yet implemented on my side. And the comparison would not be fair. So the paragraphs look similar, except for the bottom part, you see. But now I have to try to find out what causes the difference between the two. But then again, I might just say, I don't care, because I don't need perfect compatibility with TeX. just a very close visual similarity. So there's still a lot of things to do. I think boxes and glue needs a proper input language or an application besides my catalog software. But I think this is for somebody else to do. A good output routine, like with headers and footers and so on, which I've mentioned before, is something I really need. Math typesetting is not on my agenda, but I think this is important too. Documentation, as always, there is documentation on the homepage, but it's really sparse. And currently I'm working hard to fill in the gaps and much more, of course. But there are a few things that I've already implemented, such as everything that's related to fonts, font families. And I have also included the aforementioned HarfBuzz library, the text shaping library. And somebody has ported this to the Go program language, so I can easily include that, which allows me to have right to left and left to right in complex scripts. So there's PDF output. So the TEX algorithms I've mentioned, except for math. There's image inclusion, like a PDF, JPEG, and PNG, like in LuaTEX. So I'm quite happy about the state of boxes and glue. And even our football star is also a fan now. So the next step would be to experiment with the algorithms. For example, the hyphenation algorithm that I've shown, settings of priority or of the breakpoints or not preference. So that would be something to play with. So for example, we could ask the question, would the calculated maximum number during the algorithm be a good hint for the hyphenation priority? I don't know, let's find out. I've made boxes and glue as modular as possible to allow such experiments. The page break algorithm could be optimized in such a way to take a range of pages and to find the optimum page break. When TEX was programmed, the computer memory was very, we only had a few kilobytes of computer memory. It was not possible to optimize for a larger range of pages, but now we have the amount of RAM and could optimize for much more pages. And for example, we could take the paragraph or line breaking algorithm and to calculate the paragraph breaks in parallel with different settings and take whatever the best result would be. Speaking of parallel execution, modern CPUs have lots of cores which are quite bored when running TEX. So to speed up things, we should use them. Paragraphs can be broken to lines in advance where the parameters are known. A lot of applications have very predictive settings for rendering. So there should be a huge potential speed gain. And there are other areas where can gain a lot of with parallel execution of tasks, like the font subsetting. This can be done in parallel, doesn't have to be waited for each step. There's no, it's very good to be parallelized. Okay, I'm very fast today. So this is my conclusion, my last slide. And I would like to close with my conclusion. TEX is dead. Long live TEX. Of course, LaTeX will be around still in the next 20 years. But for my catalog software, it becomes more and more realistic to replace LuaTeX with boxes and glue. So in the long run, I will still use TEX algorithms, but without TEX. Thank you very much for listening.
Thank you very much for this talk, Patrick. And first of all, thank you for the explanation of the Hyphenation algorithm. That was great. Understood.
Thank you.
I finally understood it.
Good. Okay. Very well. Thank you.
Are there questions? Please raise your hand. And yes, Jonathan, I'm giving you the mic.
Thank you very much, Jeremy. Thank you very much, Patrick, for your clear talk about your interesting and important work.
Thank you very much.
I'd be very, very pleased if you and yesterday's speaker, Peter Williams of Tectonic, and Martin Ruckert, the author of Hint, would have some deep technical conversations. I'm sure that you'll learn a lot from each other because in various areas, you're handling the same problem, but for different goals. So output routines, for example.
Yes, I was going to say that Peter Williams reimplemented tech in Rust, but from what I understood, he used wrappers.
Jeremy,
yes,
this is for Patrick. I wasn't asking you to contribute. I was asking Patrick to respond to my invitation to talk with Peter Williams and Martin Ruckert.
Please go, Jonathan.
Okay. I'm sorry I have missed the yesterday's talk from Tectonic. So the other person was again who? So I can write it down and.
Oh, Martin Ruckert, the author of Hint.
Ah, okay.
But because he makes the output routine an external program.
Okay, I will take a close look because I have a very strong focus on the things I do daily, but I have no idea how to implement output routines unless I look at the LaTeX source code and with these inserts and other things that help to manage the space that is needed for the output.
I have a small contribution that might help you with the things you do daily, which is that Linux containers allow you to present external HTTP requests as a user space file system. So as far as the program in the container is concerned, it is reading a file. And that sort of technology is a way of helping to control all the problems. So that's a suggestion.
Yeah.
Which,
what I currently do,
it might be helpful.
Yeah. What I currently do, I can load libraries, C libraries during runtime with LuaTEX. And I have written a C library, actually written in Go, but it's compatible with a C library, which does all the things that LuaTEX does not handle, what I need, like regular expressions or HTTPS requests. So this is a solved problem, but it's not in LuaTEX. So, but thank you for the hint. Yeah.
And thank you for sharing once again.
Any other question for Patrick?
Frank, I think.
Yes, Frank.
But we can't hear you. I think you're.
Yeah, I have to figure out how to do it on this device. Just a quick comment on your speaking about the hyphenation ideas on extending it. If I understood you correctly, you were thinking about experimenting with whether or not the numbers actually give you a hint about priority.
Yes. Exactly.
My understanding of the algorithm is that is not going to happen because the numbers are getting higher simply by the order of which you build the tree.
Yeah.
So it goes from 0 upwards whenever it finds a pattern that is possible, and if you have a later on find that you have to refine that in the next round, you get a higher number to override it. So the numbers really depend on how the patterns are being generated. So what you would need is actually completely a new approach to building patterns. It will not help to look at the numbers.
Yeah, Bernd Reichle told me that the people from the German hyphenation patterns already have something like a priority in their mind. I haven't looked at it yet, but it would be really easy to extend TeX algorithm for breaking paragraphs into line to take some kind of penalty into account, which comes from the hyphenation algorithm. So I've not done it before because it's still in the development phase, but it should be really easy to implement that once we have.
Yeah, I agree. And it would be very helpful because especially with something like German, you want to have priorities and you will want to have that in many languages. But my understanding is that the current set of patterns, I mean, it may be that the Germans are special in the sense how they actually have been built. But in general, the algorithm just doesn't offer you that kind of information as part of the numbers.
Okay.
There is a question in the chat, if you can see it, by Michael.
Okay, there's one question. If the input is similar or the same as in TeX, so no, this is a library and there is no input language or application around it. I think that's the only answer for that. And I'm looking for somebody else or some other idea to have an input language. But since I don't use it, I'm not going to implement it.
I have another question. With the strength of LaTeX or LaTeX and all the tech things is extensibility. We have plenty of packages. By reimplementing the engine, won't you miss all those packages?
Yes, of course. I know this is a very huge drawback, and with my current implementation of based on LuaTEX, people hear, okay, you're using LuaTEX, so can I use this XYZ package to do something fancy? And I say, well, no, it's based on LuaTEX, but it is not based on LaTeX or the input language, so you cannot use it. I hope an implementation of boxes and glue would allow to be extendable in such a way that, like in JavaScript or so that many people can program their own things by accessing the nodes which are used for the implementation details. So it's not possible to use any package, and I miss it, but I hope to make an extendable system with lots of callbacks so you can jump into the code and use it for yourself.
Thank you. Are there other questions on?
I don't have any access to the other chat, so I cannot have a look there.
I can't see any other questions. I don't. We'll check also on Zulip. Okay. So thank you again, Patrick, for your talk and your work. That's really interesting to see this modern use of LaTeX form, catalogs and things like that. And that's really interesting to see you getting deeper and deeper into the engine to achieve your goals.